the technology is in the process of having a great impact on the aerospace industry. There are aerospace suppliers that are currently testing out printed parts in airplanes. There are issues with getting those printed parts into final commercial planes. Those issues are being addressed, but right now today, aviation companies are rapidly on their way to deploying additively manufactured parts into their product stream.
Certainly the most viable application for SIACI, what we call SIACI EBDM process technology, are what's called titanium fracture critical airframe structures. Primary market, but in addition to that, we have opportunities and applications in propulsion systems, jet engine components, rocket engine components, fuel cavities, propellers, propellant tank containers, etc.
Okay, the additive manufacturing process does offer several additional advantages. It reduces the amount of machining time, which for difficult to machine alloys can provide quite a savings. In addition, for the examples where we're comparing our manufacturing cycle or our lead time with a titanium forging, it's not uncommon that large-scale titanium forgings require 6 to 15 months lead time for parts that SIACI's additive manufacturing process can normally produce between 1 and 3 to 4 weeks. So it's an order of magnitude reduction in the lead time to the customer to getting a part moving on to the machining center.
There's also a strong potential for energy impacts. So additive manufacturing has been shown to be able to dramatically reduce energy waste in the form of embedded material. There's been some test case applications for the aerospace industry where they reduce what's called the buy-to-fly ratio.
The buy-to-fly ratio is a very simple number where a designer of a component would take the amount of material that needs to be procured and compares it against the net weight of the article or component that actually flies on the airplane. For example, if a component that looks like this titanium forging required that I buy 100 pounds of incoming plate stock, that I machine it and I net out a 10-pound flyaway part, that ratio is simply 100 to 10 or a 10-to-1 buy-to-fly ratio. What we've learned through working with our technology partners like Lockheed and Boeing and other major aerospace primes, it's very common that titanium forgings are purchased with a 20, a 30, or even a 40-to-1 buy-to-fly ratio. And what that means is that you buy a very expensive material, you turn the majority of that material into machining chips or scrap, and that material that you've purchased at a very expensive rate is generally sold back as contaminated chips needing cleaning, and it's sold back at a value of well under 10% of the purchase price. So that's where the value proposition comes from.